Myself, Dr. S. Indrani, Department of Electronics and Instrumentation Engineering, SRM Institute of Science and Technology. Today I am going to take Introduction to the course on Industrial Instrumentation. About the topic thermocouple. Introduction to the thermocouple. A thermocouple is a temperature sensor. It measures the temperature by converting thermal potential difference into electrical voltage based on CPAC effect. Thermocouple is also called thermal junction, thermoelectric thermometer, or thermal, a temperature measuring device consisting of two wires of different metal joined at each end. One junction is placed where the temperature is to be measured and the other is kept at a constant lower temperature. A measuring instrument is connected in the circuits. The temperature difference causes the development of an electromotive force known as CPAC effect that is approximately proportional to the difference between the temperature of the two junctions. Temperature can be read from standard tables or the measuring instruments can be calibrated to read temperature directly. Any two different metals or metal alloys exhibits give a thermoelectric effect, but only a few are used as thermocouples. Examples is antimony and bismuth, copper, iron or copper and constantan. The thermocouple principle mainly depends on the CPAC effect. This type effect occurs among two dissimilar metals. When the heat offers to any one of the metal wires, then the flow of electrons applies from the hot metal wire to the cold metal wire. Therefore, different current stimulates these groups. Different type of thermocouple. Type K, this is also termed as nickel chromium and nickel aluminum type of thermocouple. The temperature range is 450 degree Fahrenheit to 2300 degree Fahrenheit. Type J thermocouple, it is a mix of iron and constantan. Type T thermocouple, it is a mixture of copper and constantan. Application, it is thermocouple used in industrial process control, gas turbine and engine, high voltage AC systems, the food and metal industries. Next one is the non-contact type of temperature measurement. Why non-contact temperature measurement? No physical contact with the object, suitable for moving, caught or hazardous object, faster response and safer operations. Example, molten metal or rotating machinery. What is a non-contact thermocouple? Actually, thermocouples are contact-based. Non-contact alternatives are radiation pyrometer, infrared thermometers. Basic principles: radiation-based sensors, all bodies emit infrared radiation based on temperature. Intensity of emitted radiations is measured. Emissivity plays a role based on Planck's law, Boltzmann's law. Key components of a non-contact temperature sensor: optical systems, detector, signal processing unit, display output module. Next one is introduction to radiation pyrometer. Definition: a radiation pyrometer is an instrument that measures the temperature from the thermal radiation emitted by an object. It is a non-contact type temperature sensor used where contacted sensor, example is thermocouple, cannot be used. Principle of operation based on Planck's law and Boltzmann law measures infrared radiation emitted by a hot object, converts radiation into electrical signal, that is temperature display. Introduction to the pyrometer. A pyrometer is a type of remote sensing thermometer used to measure a temperature of distinct objects. Most pyrometers work by measuring radiation from the body whose temperature is to be measured. Pyrometer is also known as the infrared thermometer or radiation thermometer or non-contact thermometer used to detect the temperature of an object's surface temperature, which depends on radiation emitted from the object. These are used to measure the high temperature furnaces. These devices can measure the temperature very accurately, precisely, visually, and quickly. When any object is taken whose surface temperature is to be measured with the pyrometer, the optical system will capture the energy emitted from the object. Then the radiation is sent to the detector, which is very sensitive to the waves of the radiation. The output of the detector refers to the temperature level of the object due to the radiation. Note that the temperature of the detector analyzed by using the level of the radiation is directly proportional to the object temperature. Types of pyrometers: optical pyrometer, infrared radiation pyrometer. This one is optical pyrometer. Optical pyrometer used to detect the thermal radiation of the visible spectrum. The radiation from the source is emitted and the optical objective lens capture it. The lens helps in focusing the thermal radiation to the reference bulb. The observer watches the process through the eyepieces and corrects in such a manner that the reference lamp filament has a sharp focus and the filament is superimposed on the temperature source images. The observer starts changing the rheostat values and the current in the reference lamp changes. This is in turn change in its intensity. These changes in current can be observed in the three different ways. This one is filament is dark, that is cooler than the temperature source. Second one is filament is bright, that is hotter than the temperature source. Third one is filament is disappear. Equal the brightness between the filament and the temperature sources. Radiation pyrometer, the device used in places where physical contact the temperature sensor like thermocouple RTD thermistor would fail because of the high temperature of the sources. In radiation pyrometer, the temperature is measured through the naturally emitted the heat radiation by the body. According to the application of the device, the way in which the heat is measured can be summarized into two. Total radiation pyrometer. In this method, total heat is emitted from the hot source is measured at all wavelengths. Selective radiation pyrometer. In this method, heat is radiated from the hot source is measured at a given wavelength. The radiation pyrometer has an optical systems including a lens, mirror, and an adjustable eyepieces. The heat energy is emitted from the hot body is presented on the optical lens, which collects it. It is focused onto the detector with the help of the mirror and eyepiece arrangements. The detector may either be a thermistor or photomultiplier tubes. Through the latter is known for the faster detection of the fast moving object. The former may be used for the small scale applications. Thus, the heat energy is converted into the corresponding electrical energy by the detector and it is sent to the output temperature display device.